Welcome everybody to this year's Glow Your Own. It's the second time we've done this project. It's quite ambitious and we're wanting to go from technology trepidation to creative coding in just 6 weeks. And so there's a team of people who worked on this project last year, and you'll know it's Ada Lovelace Day today, which is a celebration of the first computer programmer, and the first computer programmer just so happened to be a woman. So despite people thinking that blokes do coding, everyone can do coding. So we're looking to make sure everyone can have a go, be creative, learn some skills, and maybe even have a nice time and develop confidence and possibly even some new friendship groups. We'll see how things go. So on the session today, we've got Cathy Rose, my colleague who worked on the festival. My name's Dane Comerford. So Cathy and I put the festival together. It's our full-time job all year round, and we really look forward to putting the festival together in October and putting projects on like this. Joining us for Glow Your Own is Sarah Townsend. So maybe if you could just say hi, Sarah.
Hi everybody. I work for Science Oxford, so I run lots of cool coding workshops all year round.
So Sarah's really good at troubleshooting. So if you have a problem, put something in the chat. Also, we've got CJ, who is our artist. So CJ, if you could say hello.
Hello everybody, I'm CJ. I'm based in Newcastle, but kind of for this project working between Newcastle, Leicester and Oxford. I do Arduino creative for creative purposes, and that's what I'll be kind of bringing to this. And I'll take you through some of the physical setups of the Arduino, and then hopefully leading to some small creative sculptures. So I look forward to sharing this these 6 sessions with you.
And next up we've got Sophie. So Sophie, if you could say hello.
Hey everybody, I'm Sophie. It is lovely to see all of you here. I'm very excited and looking forward to working with you over the next 6 weeks. I work at Rutherford Appleton Laboratory, which is behind me, which is a really big lab where we do lots and lots of fascinating experiments, and we use coding and Arduinos all the time. So I'm really excited to share that with you.
Great, thanks Sophie. Okay, so hopefully everyone's got Tinkercad nicknames. If you've not got that, please shout help in the chat and I will find your Tinkercad nickname for you, and that allows you to log in, and that should make sense in a few minutes when Sophie gets started. So enough of me, let's get coding, shall we?
It's time to start coding. So I just popped in the chat a link to our Tinkercad classroom, and that's really going to help us all. If we're all on the Tinkercad classroom, that means that we can see your code and we can help you figure out if anything is going wrong. And personally, whenever I start to code, I always get something wrong to start with. Debugging, fixing those problems is the most enjoyable part of it, because it's so satisfying when we get it right. So if you all go to Tinkercad, the link is in the chat, and then put in your nickname that you should have got yesterday. If you don't know what your nickname is, pop something in the chat and Dane and Sarah will send you your nickname. It should be start with GYO dash, and then there's another bit, but Dane is on that. And while he is doing that, I will get started with the coding, but don't worry, we won't start the actual coding until everybody is logged on. So if you could put a thumbs up or a hands up or something to let us know that you are in Tinkercad, then that would be brilliant. Right, I'm going to share my screen. So once you have logged on using your nickname, you should see something a bit like this. Once you're in, remember it's the nickname that you need to pop in. So once you've got this beautiful entry thing, what you need to do is go over to create a circuit. So over here on the left, you've got a thing called circuits. And you can see I've actually created a whole bunch of different circuits already. But what we want to do is create a new circuit Thank you to everyone for your patience as we're just getting all of your nicknames ready. So once you clicked on circuit, you create a new circuit with this button, so create new circuit. And then we get something like this. And this is where we're going to create, we're going to start doing our coding. We're going to learn all about how Arduinos work. Okay, so when you have got to this point, give me a wave or a thumbs up or pop something. That would be brilliant. So when you can see this. Brilliant, James is there, Javier's there. Fantastic. While we're just waiting for everyone to catch up, do have a look on this right-hand side. Sorry, you'll learn that I'm not very good at left and right. I will try and get them right, but Sarah, CJ, Dane, if I ever say the wrong one, please just shout at me, okay? So over here on the right, you can see all of the different kinds of components that you can use. And there are lots and lots of different components, and CJ is going to be telling us about them as we go through. But Tinkercad is really great because if you click on this thing saying switch to list view, it gives you a little description of what all of these are. So if you forget one of them, you can always go and look at this and that will tell you exactly what it is. All right, so I'm just going to show you once more how to get back to here. So once you've logged on to Tinkercad, then you click on circuits over to the left here, saying circuits, and then create new circuit. Right. And then you should end up with a page a bit like this. Right. Okay, so the first thing that we want to do for our Christmas lantern, I think what's nice in a Christmas lantern is something that makes a light, something that glows, light in the darkness. That's what a Christmas lantern is all about. But in order to do that and control that, we are going to use something called an Arduino. And Arduinos are on the component list. So if you go down a bit, you'll see this one called Arduino Uno. And all you need to do is click on it and then drag it out over here. You can move it around wherever you want. But I would put it towards the left-hand side of it, just so that you've got plenty of space to do that. This is an Arduino, and some of you might not have heard of Arduinos before. So CJ is going to show us a real live one, and also, oh, there we are, and also explain a little bit about the Arduinos, just while Dane is sending you all the nicknames for those people. So
Okay.
CJ?
Thank you, Sophie. Okay, so this is our Arduino microcontroller. So Arduino is basically the platform that we'll be using, and it is split into kind of two different strands. One is the microcontroller, as the physical thing is what I'm holding here, and the other part of Arduino is the software. It's kind of the integrated development environment. It's the IDE. And that is the thing that will run on your computer, and we'll use that to kind of upload the code to the physical board. So once you have this, and then you'll have a lead like this. It's a USB. One end plugs into the Arduino, and the other one goes into your USB on your laptop or computer. And then once we have that all connected, we'll then have a software that will do, possibly either today or the next session, that you download on your computer if you haven't already. And that's for Arduino Uno IDE. That's to allow you to input the code. And then therefore we're going to have the microcontroller and the integrated development environment communicating to each other. And that's how that's the basis of how we'll start making things work. So making LEDs light up, using buttons to do that, etc., or making servos. So that's what That's the microcontroller, and it forms part of the whole of the Arduino.
Thank you, CJ. I think Arduinos are amazing. Have I ever told you, CJ, that what one of my scientific computing friends here, how they described what a microcontroller was?
Go on.
I'm not sure I have. So if you just split the word up into two, micro means small because it's a small thing. I mean, you saw CJ holding it up, and a controller is something that controls other things. And so that's all it is. It's a small thing that controls other things. And I thought that was a really good way of describing what it does.
That is.
Yeah, it's pretty cool. Cool. Right. So the next thing we need is called a breadboard. And you can find the breadboard on the component list just above the Arduino. So you click on it and then you drag it over to the side. I'm just going to move them a bit so that they're separated out a bit, like this. Now, I can't remember why these are called breadboards, but they are. Oh, why are they called breadboards, CJ?
Apparently, it's because when the electronics were really big and bulky, people used to set up the circuits onto the house breadboard, literally the board that people make bread on. They used to set up the circuit on there, and that's where the name comes from. It's as simple as that. They used it as just a base, an actual bread cutting board.
That's pretty cool.
Mm-hmm.
So yeah, we're going to use our breadboards. I love that. I love that's where it comes from, to help make our circuits. So to help send instructions from our Arduino to our lights or whatever else we're going to do. So CJ, do you want to show the real breadboard?
And you can this size, and they also come longer. You can get kind of double-sized ones as well if you're using lots of components. But this is the standard size one here, and it's exactly the same as what you can see digitally on the screen. And it basically contains this very complex system, which I will not go into the details, but basically contains little metal strips inside, and they're all conductive. So it allows all of the electricity, all of the currents to flow in series on this board. In a nutshell, that's what it is used for. So we'll be building the circuits on these, and then connecting the wires from here to the Arduino, and that's how we can kind of compute our sensors to do things.
Absolutely. I love breadboards because you will learn, again, I'm not very good at left and right, but I'm also not very good at doing things with my hand. I'm not good at connecting things. And so when I want to connect, if I wanted to connect my Arduino to my light, say, if I had to do it with long, thin wires and connect everything up, I would definitely make a mistake. But with the breadboard, like CJ said, because it's all connected inside, all I need to do is pop them into the little holes, and then the breadboard does the connecting for me. And what Tinkercad is really good at is it will actually show you which holes are connected to which other holes. So if you can see, I'm hovering over it, and you can see that all of these 5 holes along here are lit up in green. There are little green circles around them. That's because they're all connected. And then if I go down here, if I go to one of these rows, this whole row is connected to each other. And so that will help you see what is connected to what. So what we want to do now, if you do have any questions just before we do the next step, please do pop something in the chat. Sarah is fantastic at helping through just a tiny little bit of text. She's brilliant. And do always remember that that you can always watch the video afterwards. You can pause me. I'm sure there are some people who would like to do that in real life, but you can pause me, make sure that you're up to speed, and then carry on as you want. Okay, so we're going to do one more component. The next component is our light, which in electronics, with these Arduinos, we call an LED. Now that stands for a light emitting diode. And so again, you just click on it and drag it over. But this time, instead of just dragging it over into the middle of the screen, we are going to drag it over and put it on our breadboard. So you can see that I could put it into the breadboard and it's kind of clipping in to one of the two spots. So I'm going to pop it here. You can see that now the LED is connected to this row 20 and row 19. And over here, you can see that because I've clicked on my LED, I can change it. So I can give it a name. I think I will call it Ada because it's Ada Lovelace Day. But you can call it anything you want. You don't, or you can just leave it with a number. And you can change the color as well if you want. So you can have a light of any of these colors. I'm going to keep mine with red because I think that's a nice color to start with. But you can change it to whichever color you feel like, whatever color you want. So CJ, do you want to show a real LED?
As in separate, yeah?
Yep.
This is the real light emitting diode here. It's literally one of my favorite things in the world, these tiny little LEDs. It has one long leg and one short leg, and we'll find out bits about that. But basically the longer leg is always going to be used for positive things, and then the short one is the negative side. So we'll learn how that links up to the breadboard and using both the positive and the negative sides of the circuit. So the longer leg is positive and the shorter leg is negative. And basically, this, once you've got the circuit complete, this basically is electrical energy being converted into light. That's as simple as that, and simple and as beautiful.
It is. I think that the simplicity of it is really beautiful. You're right. So you can see that CJ told you positive and negative signs. So if you hover over the bits of the LED, it will tell you some fancy words for that, which they use in electronics called cathode and anode, but you don't have to worry about those. Tinkercad will just tell you. Right, so we want, so we've got our nice LED, but unfortunately it's not connected to our Arduino, so we're not able to send any instructions or any power, or any energy to it. So we want to connect our LED to our Arduino so that we can tell it to turn on, because that's the exciting thing for today, isn't it? So those of you who remember, who have done or who remember electricity, doing electricity and circuits at school, will remember that you need to have a complete, what we call the complete circuit that goes all the way around. So the first way I'm going to connect my my Arduino to my circuit is I'm going to use a wire, and wires are really easy on Tinkercad. All you need to do is click where you want the wire to start, click on which hole or pin, and so I want to get my Arduino to start down here in pin 4 of the Arduino. So you can see that these little holes, these are ways we can send out instructions, or we can learn what's happening. So I'm going to click on pin 4. They're all numbered. And then you can see that it draws a wire. And I could put this wire anywhere. I could put it over here. I don't want to. I could put it all the way up here. But I want to connect it to my light. So I'm going to connect it here to this right-hand side of the wire. So you can see that it's now connected. It goes, the electricity, once it's plugged in, will go from the Arduino up here, out of pin 4, all the way to the breadboard, through the breadboard, and you can see the connections of the breadboard, and then up to the LED.
And that's the going to the longer end, isn't it, of the leg of the LED, the cathode?
It is,
yeah.
Yes. Absolutely. All right, but then the LED, the electricity gets to the LED and it's like, oh no, I've got nowhere to go. So nothing's going to happen until we create this complete circuit. So once you pop the wire in and your LED, you just want to put your hand up or anything. So put your hand up, give us a thumbs up just to let us know to see if we've got some people at this point. Oh, Pam has, excellent, good job. Alec has, fantastic, well done everybody. You have all of these cool, we've got some lovely thumbs up from James and Steph and Danny. Oh, somebody waved. I don't know how to do that. I'm not even sure how to raise my hand at the moment. You're doing brilliantly. Fantastic. So now what we want to do is to go from our LED back to our Arduino. And we could go straight from there back to the Arduino, but we actually don't want too much energy to go to the LED because it would be too bright and that wouldn't work. So we are going to use something called a resistor. Sorry, excuse me. Clearly I've been talking too much today. We're going to use a resistor to make sure that the LED only gets the amount of power, the amount of energy that we want it to get. So next to the LED on the component list, you can click on this resistor, bring it over here, and we want this resistor to go from the other leg of the LED all the way down to this minus line here. So you can see, I'm just going to zoom in. I'm going to try and zoom in. There we go. So you can see a bit better. So we're going up from the LED, and then we go from, we go to this resistor, and that goes down to this line. Now, CJ can show you a real resistor. They're really fiddly, I find.
Yeah. And sometimes it's worth, when we're putting them in the breadboard, with them, if we've got some pliers or something, we can shorten the leg, can make it a bit easier to pop in into the little pins on the breadboard. So yeah, they're very small, really tiny, and these you might see clearer on Sophie's, on the digital one, that there's different coloured bands. We won't go into details about what that is, but basically the different colours basically suggest what how many ohms they're carrying, and ohms is obviously our measure of resistance. So if we've got the higher the ohms, the less electrical current will pass through the circuit. So it depends on how much we need to go to our LED or any of our other sensors. Depends on which resistor we're going to use.
Absolutely. Thank you, CJ. So when you're doing it with real resistors, you've got to pick the right one. Helpfully in Tinkercad, you can just tell it which one you want. So if you click on it, you can see that again, you can give it a name. So you could give it any name that you wanted. So I'm going to call it, Lovelace. I guess you don't have to give it a name, but today's Ada Lovelace Day, so I feel like I should. And then you can change this resistance that CJ was talking about. So we can change the amount of energy our LED will get. And so the best number for this is 220 ohms. So you can change that by going 220 and then changing this to this little squiggle without another letter, which is called an ohm, which is quite a nice word now I think about it. Yeah, so that will just make sure that our LED isn't too bright, which is what we want. And once we've done that, we still don't do we still don't have what we call a complete circuit. So to get this, to change this number, remember you need to click onto your resistor, okay? So if I click onto the LED, I can change my LED. If I click onto my resistor, I can change my resistor. So at the moment, we've got nearly a complete circuit. We go from our Arduino all the way up through the wire into the LED, into our light, goes through the light, and then it goes back to the resistor, and then it stops. So we need to make one final step that will go from our breadboard from here, so from the resistor back down to the Arduino. So we're going to make another wire, and we're going to click on this one next to the blue line, click on that, and then go down to the pin that's labeled GND. Now that means ground, which is like a way of saying negative. That's the negative side of it, the ground of it. That's where we end up on our circuit. Right.
Sometimes for ground, a lot of the time for ground, we like to use the black wire just so we can identify things later on. It's nice to keep color consistency, and
yeah,
black wires are usually used for ground wires like this one here. And I think you can change the color on Tinkercad as well.
You can indeed, yes. So it is so the color of the wire doesn't make a difference to the circuit itself, but it does make it easier for you to spot what's going on, and it can make it pretty. So, like CJ said, it's a good idea to change it, and you can change it by clicking on the wire, and then you can see up here you've got these little things that say color. So you can change that to whichever color you want. But like CJ said, it's a good idea to have it as black or brown sometimes to say, oh, I'm going to ground. Right. So now we have what we call a complete circuit. We go from here into pin 4, all the way up to LED, through the LED to the resistor, along the breadboard, and then back down to the Arduino, which is fantastic. A complete circuit. So give me a wave if you've got a complete circuit. CJ has, that's good. Brilliant. Isaiah has, Finn and Evan have, Jaden. Oh, fantastic. Oh, Steph has asked a really good question. Why do we use pin 4? That is a fantastic question. And the answer is because pin 4 was what I picked. So it doesn't actually matter which pin, which of these pins along here that we use. What we need to do is to make sure that we are sending instructions to pin 4. And in another few weeks, when we're doing lots of different things with lots of different LEDs and buttons and all kinds of exciting stuff, we will be using lots of pins, and we can send one instruction to an LED that's connected to pin 4 and a different instruction that's connected to a pin to pin 8. So you can pick whatever you want. While we're doing this all together, it's quite sensible to use the same one that I'm using, just so that we don't get muddled up with who is doing what. But you can pick whichever one you want, and you can put these in whichever little holes you want, as long as you have that connection.
Should we say about the digital versus analog yet?
Oh, that's a good idea, CJ. Yes.
This is a good time. Yeah. Not too complex, but basically, as you can see on both sides, they are digital and then analog pins. So we have one strip that's digital, and some of them have a little curve, a little wave next to them. That's the pulse width modulation. That's something that if you want to research yourself, you can. It's not super essential, but basically that's part of the digital side. And the digital pins, we usually use them for turning an LED on and off. So it's digital input and a digital output. For example, if we want to use a button, that's a digital input, and then having the digital output as the LED. So we use digital pins for that. I hope that makes sense. And it's usually within the kind of on-off, would we say binary here? That's why we use digital. Whereas the analog on the other side is something that's maybe more variant. So for example, if we want to use a sensor that measures temperature, it's more on a scale that will vary. That's when we'll use an analog pin. So that there on the other side, there's not as many on there. There's, how many are there? There's 5. Six of those, and that's yeah, when we want to convert something that's analog into a digital, so we can read it, so we're able to read it. So that might be a temperature sensor, or even a light that perhaps changes in its brightness, for example. Is that right, Sophie?
That is, yep. So digital is really good if we just want an answer that's yes or no, or we want to send a thing that's on or off. Analog is really useful if we want to be a bit more complicated. So we want to say, I'd like it to be a little bit hotter than this, but not a lot hotter than this, or move a tiny bit, but not too much. Right. So we've been talking about instructions and sending instructions to it. And now we get to do the thing that is my favorite bit of it, coding it. So writing those instructions, which we call code. And you can do that on Tinkercad really easily by clicking this button over here on the top right that says code. And if you see that, this whole new mess of stuff comes out. And some of you will think that this looks pretty familiar, because this looks pretty like Scratch, which some of you will have done at school. It's a really nice way of being able to code, to write instructions for our Arduino without having to do lots of typing, which my fingers get tired, so it's a good thing. So this is what we're going to use to write our instructions. So when you first do it, you'll see that it comes up with some automatic ones. We don't want those because we want to do something much more interesting. You press the code button up here to get this, remember. So to get rid of this, all you need to do is click on it and then pull it either down to this little rubbish bin in the corner if you want to delete something. So now that's disappeared. So I can show the code by pressing this button saying code up here. You click it, it appears, and if I click it again, it disappears. All right, so if I click it, then it appears. So give me a wave if you've got your complete circuit and you're ready to start coding. Fab. Lots of waves. This is great. Thank you, everyone. Brilliant. So now we're going to do a nice, simple bit of coding to say, Arduino, I want my light to turn on. I've got my light and I definitely want it to be on. So what we're going to do to start with is something, we're going to use a block called control over here. And we are going to use this third one down, which is called repeat while. Now, this is a really, really useful type of code. So to get it out, all you need to do is click on it and then pull it over to the right. Okay, so that's the first bit that we need. And what this is going to do, yep, just like Scratch Checkup, it's really, really good thing to do, a good kind of programming for you. So once we've done that, we want to tell the Arduino to just turn my light on forever and ever and ever. And what this bit of code does is it's going to send whatever instruction is in here to my Arduino, to my light. So I'm going to put what we call a condition in here. So it's going to ask a question, and if the answer to the question is yes, it'll do whatever's in here. So if you go to the math function here, you'll see all of these different bits and pieces. We want the diamondy one, the second from the bottom, and you bring that over and then you click it and you pop it in to that, and it makes a satisfying pop noise. So everyone there? So instead, but this asks the question, computer, Arduino, is 1 less than 1? So you'll remember from your maths classes, or you might not have got there yet, depending on where you are in school, that this little arrow sign means less than. So is 1 less than 1? 1's not less than 1, so that's not going to work for us. We want something that's always going to be true. So if you click on the arrow, you can change this to an equals sign, the third one down. So you can say, computer, is 1 equal to 1? And the computer is going to say yes, because it is. All right, I'm just going to give you a minute to catch up. So remember, you want to get, you want to get this orange block, repeat while, and then you want to, that's from control. Really helpfully, the blocks are the same color as the little sections as well. So it's quite easy to find where they are. Repeat while 1 equals 1. So that basically means Arduino, always do this forever and ever and ever. And what do we want to do? Well, I want to turn my LED on. So that is what we call an output, sending an instruction out to our circuit. So if we go to the output, then you'll see there are lots of different things that we can do. And what we want to do is we want to set a pin. We want to send an instruction of on or high to pin 4, because that's what our LED is locked into. So you need to do this, set pin 0 to high. So you just pop that in and it should click in like that. So if you're signed on with your nicknames, Sarah and Dane, we can all see the code that you're doing, so we can help if you have any questions. So if you do have a question, do let us know what your nickname is so we can make sure that we're looking at the right one. So what this bit of code would do is would send an instruction, turn on to pin 0. So high means turn on, and this is which instruction it would be. So if I use this, nothing would happen, because the Arduino would go, okay, I'm sending an instruction out from pin 0, but there's nothing connected to pin 0, so nothing's going to happen. So I want to change this pin to whichever pin my LED is connected to, which is number 4, as I can't remember who said. Okay. Right, so I've changed that to set pin 4 to high to on. So what this will do, it'll say, Arduino, is 1 equal 1? And the Arduino will say yes. And it'll be like, okay, well, send an instruction saying turn on to pin 4. So if this is all right, if we've done everything right, then when we run our code, it should turn our LED on. If I've done everything right, which often doesn't happen in the first time. Now, what is really nice about Tinkercad, and which I'm sure you'll all be really grateful for over the next 6 weeks, is we can actually use this to make a pretend Arduino. So we can what we call simulate. We can test out whether our code works before we send it to like a real physical Arduino. And that's really helpful, because it means that we can tell for sure if the problem is in our code or if it's in our physical Arduino. Because sometimes, CJ, it's often quite difficult, isn't it, to get all of the connections right in the circuit. Sometimes they come loose.
Mm-hmm.
And it's really helpful to know what you're looking for, isn't it?
Yeah. Keep them as clear and organized as possible.
Yeah.
That's what I've learned.
Absolutely.
Spacing in between.
Yeah. Dane seems to have sent a picture of a cat. I'm not sure why, but I'm sure he had a good reason. All right. So we are all, if you give me a wave when you've got this code and you've got this circuit, let me know if you're ready. We can test out our circuit. Fab, we've got some waving, Javier, and Andrew's there, and Jaden. Oh, apparently the cat means he's happy about something. That's good. Ryan. Fab. We've got a thumbs up from Helena and Joseph. Brilliant. Good job, everyone. If we are, if you're not quite there, that's absolutely fine. Remember, it is all on, it's all being recorded. We will share the recording with you so you can watch it, you can pause it, and the instructions are also in my magic piece of paper that you can only see the bottom of it, but I promise you it's real. All right, so we are all ready to start and test our circuit. And in Tinkercad, what you do is you go up to the top next to the button that says code and you press start simulation. I like to cross my fingers to make sure it works. So I'm going to start my simulation. You'll see it's thinking about it. And then, did you all see my light turned on? Woo! Which, yeah, I'm pretty pleased with that. Did anybody else's light turn on? I saw that some people said they were working. Luke was working. Fantastic. Give me a wave if it's working. Param's working. Fantastic. Isabel's light turned on. Raoul's, oh, fantastic. You're all amazing. This is so brilliant. Well done, everybody. So I can stop my simulation and my light turns off. And I can start my simulation and my light turns on, which is brilliant. Oh, honestly, they're doing so well, CJ, aren't they?
Yeah, excellent.
Fantastic. I'm so impressed, everybody. I think it took us longer last time, didn't it? You're all clearly experts. We're going to have to speed up for next time. One thing just to point out, if you look over here at this side of my Arduino, watch what happens when I stop the simulation and I start the simulation. So you see when the simulation has stopped, the USB, the cable is not connected. And when I press start, it moves the cable to be connected. And that's really important. That's giving it power and saying, right, we can start doing this now. When we move on next week to doing it with the real physical Arduinos, what's really important is that when you're changing the components, when you're moving them around, adding a resistor or an LED, that whenever we're doing that, we don't have our circuit connected to the computer, to our power source. And that's because it's just good practice when you're doing circuits in general, that when you're changing a component, you don't want it to be powered. Now, our Arduino hasn't got very much power, so nothing bad would happen to you, but we always make sure that we follow what we call good practice. We always make sure that we are as safe as possible so that we don't have our Arduino connected to our computer, which is our power source, when we are changing the circuit. So that's really important to remember, and you will probably get tired of me saying that, and CJ saying that, and Sarah saying that in the chat, and everybody saying that.
Safety 101.
Yep, absolutely. It's the most important thing. All right. Well, since you have all done so brilliantly, I think we can move on to the next bit of the code, which is making the LED do something a little bit more exciting than just turning on. Just turning on is pretty cool, but I want it to do something a bit more interesting than that. I would quite like it to flash. Turn on and off and on and off and on and off. So I'm going to change my code. I'm going to add to my code to make it do that. Now, so if this turns it on, I can change my code. So instead of saying, Arduino, send an instruction to pin 4 that says turn on, I want to send an instruction that says turn off. But I can use the same block. So I get this here, set pin to high. And I can pop that in here. It's still to the same LED. And so I want to keep that to pin 4. But instead of saying on or high, I want to turn off or low. So set pin 4 to high and then set pin 4 to low. All right, now, If we simulated this, the computer, yep, absolutely echo, high is on and low is off. That's what CJ was talking about with the digital. Sometimes we say 1 and 0 is digital. Sometimes we say on and off. Sometimes we say high and low. We use lots of different ways of saying it, but that's exactly right. Well done. Now, if I send this code to the Arduino would say, all pin LED turn on, LED turn off, LED turn on, LED turn off, which would be great. But computers are much, much quicker than we are at some things. They're definitely much quicker than our eyes. And so to make sure that we can see it turning on and off, we want to have a pause between each of these two different things. So if we go back to control over here, you can see there's a button called wait. A block called wait. So I'm going to pull this wait button, this wait block out, and I'm going to put a pause in between turning it on and turning it off. Now you can change it to however many seconds you want, or you can even change it to milliseconds, but I like to keep it for seconds for this. So I'm going to change this to half a second. So it would be on, it would wait for half a second, and then it would be off. But then it would go straight back to turning off, to turning on again. So we want another wait after the turning off here to 0.5 just here. All right, so what should happen, yep, concentrating powerfully, and well done, Yusuf, is we want to turn it on and off and on and off. Let's see. Oh, Isaiah's works, fantastic. I'm going to start my simulation. Fingers crossed. On and off and on and off and on and off. See, it's working. Oh, Ryan's is working too. Jakob's is working.
给我。你干嘛呀？你我这正开着车呢啊。
Everybody, fantastic. We've got a bunch of people's working, which is brilliant. We've got flashing. Oh my gosh, you are amazing, everybody. I'm so pleased. I never knew that cats meant happiness, but Finn and Evan, apparently, they're happy. That's great. Brilliant. We've got smiling faces, more cats and happiness. It works. Fantastic. That is brilliant, everybody. So I think that's a pretty good start to a Christmas lantern. If you think about a Christmas lantern in your head, you can imagine lots of different ways, but often it's got some kind of twinkling light, like on a Christmas tree or something. So you have all taken that first step to being able to create your Christmas lantern. And we use things like this on here at site to get here at site to do our experiments. We turn things on and off really, really, really rapidly, sometimes much more rapidly than this. Oh, hello, Norwich Home Ed Co-op. And Yusuf, fantastic job. You've been doing brilliantly. So we use this to turn our lights on, but on and off really quickly because sometimes we want to illuminate something with a flickering pulse, but our lights tend to be a little bit more powerful than this. Sometimes we use X-rays, sometimes we use lasers, all kinds of cool stuff, which we will tell you all about as we go through the series. So we've just got another couple of minutes now before we wrap up and we move into the troubleshooting. So as a sneak peek, next week we are going to be using this, and CJ is going to be building physical circuits with us.
Yeah, want to see a quick sneak of some lights on the physical?
Yes, please.
All right, so basically what you've done there, but I've just got 2 more LEDs and I'm using a button to switch them on. Can you see? Hang on. There we go.
It spotlighted you.
Right, let's do this. Bear with me, because it's not easiest thing without, but though. So I've got 3 here, like a white one, a red one, and a blue one coming on and off. That can be coded like this without the button to come on like this in series, or with a button. And we'll be exploring some of these things in the next few weeks. And then as well as that, we'll be exploring how we can embed these groovy lights into something creative and maybe more remote, so they're not in the breadboard. The lights are actually in a piece that we make, in the lantern, for example. So that's really exciting.
It is.
I can't wait.
Zane has clearly found where the emojis are stored, so he's now put a light bulb in the chat.
Yeah. Exactly.
I can't wait to see you all doing your physical circuits. So what we'll be able to do is we'll use the same code. We'll make our circuits on. We'll always make our circuits on Tinkercad. We'll always check them to check our code is working. But then we will be able to send our code to a physical Arduino, and we will show you how to do that in the next session. All right. Thank you all so much for your hard work, everybody. I'm so impressed. I'm going to hand over to Dane to wrap us up.
Right, great. Well, I hope I've unmuted myself correctly. And Brill, that was amazing. I was so happy to see so many people getting coding success. Yes. I know some people didn't, but that's fine because you can watch it again. But thanks so much, everyone, for joining in. It was great fun. Thanks, CJ. Thanks, Sarah, for doing loads of troubleshooting in the background with me. It was amazing again. And obviously, thanks, Sophie, for such a clear introduction to Tinkercad and the digital Arduino. And then, CJ, it was cool to see the real build. And that's what we'll be working towards over the next 6 weeks. So hopefully, we'll be having lots of flashing lights built up. I do love the use of the chat function. It would be helpful just to not maybe have so many lines of happy cats, because it makes it difficult to see when the messages come through. So if we can be a bit more subtle maybe with the use of the emojis, that will be awesome, just to keep things under control with the chat box. But I'm really happy that everyone's enjoying themselves and having a good time. I'm really looking forward to seeing you next week, and for the next 5 weeks, in fact. So happy Ada Lovelace Day. It's a good thing to celebrate. Bye for now. See you next time.